All right, in section 4.3, we are going to start looking at quadratic functions and their properties, okay? So, you know, when you get the final exam on the last day of class, everything's going to be mixed up, okay? You're going to have lines, you're going to have circles, you're going to have parabolas, you're going to have exponential functions, you're going to have logarithmic functions, and you have to be able to recognize from the equation what you're dealing with, okay? So far in this class, you know, we've looked at lines, okay? So we know that a line is, the equation is going to be y equals mx plus b. And we recently looked at circles, okay? And we know the equation for that is going to be x minus h squared plus y minus k squared is equal to r squared, okay? So here comes another type of equation, okay? It's going to be a quadratic equation, okay? A quadratic equation is anything that can be written in this format, okay? F of x, which is the same thing as y, is equal to ax squared plus bx plus c, okay? So an example of a quadratic equation would be, I'm just going to make this up, y equals negative 13x squared plus 10x plus 1, okay? You have a number times x squared plus, or yeah, a number times x squared plus or minus a number times x plus or minus another number, okay? So remember, if everything is mixed up, you can recognize a quadratic by the highest power of x being the second power, okay? You are being able to recognize the a, b, and c is very important. It's actually the same a, b, and c from the quadratic formula. So if you don't remember the quadratic formula, I'm about to talk about it. It does involve the a, b, and the c. A is always going to be the number in front of the x squared. Okay, so here a would be negative 13. Okay, b is always going to be the number in front of x. So b would be 10 here. And then c is always going to be the constant. So it's 1 in this case. Okay. If you don't remember the quadratic formula, it is coming back. You will use it in this section, not immediately, but by the end of this section, you will use it, okay? It is on the last page, page 6 of this packet of notes, okay? I'll go ahead and write it up here, okay? It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, okay? So start trying to put it back into your memory. It is something you will have to memorize for this class, okay? All right, our focus in this section is going to be graphing a quadratic equation by hand, okay, and looking at its attributes, okay? All right, so if you have something in this format, y equals ax squared plus bx plus c, something quadratic, okay, its graph is a special type of U-curve called a parabola, okay? So a parabola, you've probably seen it before. I'm going to go down here. A parabola, you can have one that looks like this, where it opens up, okay? Or you could have a parabola that opens down, so it might look like this, okay? Kind of silly, but it works. Just remember, up is happy, okay? Down is frown, okay? When you get your equation, you can tell from the equation whether you're dealing with something that opens up or down, okay? All you have to do is look at the a value, the number in front of x squared, okay? If the a value is positive, so I'm going to put a is greater than 0. If the a value is positive, it's going to open upward, okay? And if the a value, the number in front of x squared, is negative, it's going to open downward. So you can tell immediately from the equation, okay? If I go back up to this equation that I made up, okay, the a value is negative, so this would be a parabola that opens downward. So it would look like this, okay? All right, so let's try to fill in some of these blanks that I have up here, okay? We'll come back to vertex in just a second. But it says that the parabola ax squared plus bx plus c is going to open upward if the constant a, which is the number in front of x squared, is positive, okay? And then the parabola opens downward if the a value is negative, okay? And then the rest of these blanks are talking about something called the vertex of the parabola, okay? The vertex of a parabola is its central point, okay? So let me go back to these little graphs that I drew down here, okay? The vertex for the parabola that opens upward is going to be right here where I'm putting the x, okay? That is the point on the parabola. That's kind of its central point. The parabola, if you folded itself along that point, like, well, I don't know. That's more the axis of symmetry, which we'll get to in a second. But this is kind of the central point. It's like if I were traveling along the parabola, once I get here, I'm halfway done. And then I keep going and I trace out the other half, okay? And then if I were dealing with a parabola that opened downward, this would be the vertex, the central point, okay? Kind of the halfway point, okay? All right, so let's go back to filling in our blanks. So if we're dealing with a parabola that opens upward, we know that's the case if your A value is positive, okay? And in that case, if you're dealing with an upward opening parabola like you are here, the vertex is going to be the lowest point on the parabola, okay? And if you're dealing with a parabola that opens downward, as in this one, as in this case, your vertex is going to be the highest point on the parabola. Okay, and this is actually going to be important. It's helpful to know when you're graphing a parabola whether the vertex is going to be the high point or the low point. And when we get to section 4.4, which is quadratic word problems, so it's word problems that involve in quadratic functions, okay, the word problems are not too bad because all they're going to be asking for, they're going to give you a quadratic function, and you're going to be asked to either find the maximum or the minimum value. So all you're going to be looking for is the vertex, okay? All right, like I said, in this section, our focus is going to be on graphing a parabola by hand. You will certainly have your calculator on your test, but it is something that's good to know how to do by hand, and I will ask you to show your work anyway. When you graph your parabola, you are going to start by finding the vertex. You need to know where to center your parabola, okay? So there is something called a vertex formula that's going to help us calculate the vertex, okay? Now, if we think about it here, okay, say I have my x and y axes, okay, and I have a parabola somewhere, okay? I'm just making up some random parabola, okay? So this is a parabola that opens upward. This would be the vertex right here, okay? That vertex is located at some xy pair, okay? So the vertex is going to have an x coordinate and it's going to have a y coordinate, okay? So this vertex formula that is given, I'm about to tell you what it is, it only tells you how to calculate the x coordinate of the vertex. The vertex formula is x equals negative b over 2a, okay? And it's the same a and b from the earlier identifications. The a is the number in front of the x squared and the b is the number in front of x, okay? So x equals negative b over 2a, that's going to give you the x coordinate of the vertex, okay? There is no formula for the y coordinate, okay? To get the y coordinate, because you need it, okay, you're going to take the x coordinate that you calculate for the vertex and you're going to plug it into the original equation, okay? And that'll give you the y coordinate, okay? And I'll even put that right here. To get the y value of the vertex, plug the x coordinate of the vertex into the original equation. Okay. All right. So I have a blank here. Okay. It says the vertex of the graph of a parabola is the point blah, blah, blah. Okay. So this is asking for an ordered pair. It's going to look a little mathy here. We know the x coordinate is going to be negative b over 2a. Okay. To get the y coordinate, you need to plug that x coordinate, which is negative b over 2a, into the original function. Okay. So that's how you write it all mathy. Okay, but you just need to remember, if you're trying to calculate the x coordinate of the vertex, you need to apply the formula x equals negative b over 2a, and then you get that x value and you plug it into the original equation to get the y coordinate. Okay, and that's going to be your vertex or your central point of your parabola. Okay, another feature that all parabolas have is something called the axis of symmetry. okay? Basically what it is a vertical line that goes through the vertex of your parabola, okay? So again, I'll look at this little graph that I kind of randomly made here. So if you were to draw a vertical line through, I'm just putting it as a dotted line, if you were to draw a vertical line through the vertex, okay, the parabola would be symmetric about this line. Okay, so if you took your sheet of paper and you folded it along that green dotted line there, the left side of the parabola would lie on top of the right side. Okay, so that's what an axis of symmetry is. It's a vertical line that goes to the vertex and your parabola is symmetric about that line. Okay, you are going to have to use the axis of symmetry sometimes to graph a parabola. It can be helpful. You'll see that in the following examples. But you're also going to have to write it down. It is a vertical line, so you're going to have to write down its equation. Okay, if you think back to our section on lines, which was 2.2, we talked about the equation of a vertical line. Remember, it's going to be x equals if you're dealing with a vertical line, not y equals. It's going to be x equals. Okay, and it's the equation of the line is going to be x equals the x coordinate of the vertex. So it's going to actually be x equals negative b over 2a. Okay, we'll get more exposure to this when we do the actual examples. It'll make more sense when we get into that, but just kind of keep that in mind of what it is. It's a vertical line through the vertex, and you're going to have to write down the equation of that line, which is going to be x equals the x coordinate of the vertex. Okay, all right, so that's kind of the terminology that's involved with parabolas. Okay, like I said in this section, we are going to concentrate on graphing a parabola. And then after you have the graph, you're going to talk about its attributes like domain and range, where it's increasing, decreasing, those kinds of things. Okay, so at the very bottom of page 1, I have some techniques written down for how to graph a quadratic function. Okay, there are 3 different things. Okay, we're going to focus on number 3. Okay, so let me just talk quickly about the other 2. If you don't know how to graph anything in math, you can always resort to making a table of values where you pick the x values, you plug them in to get a corresponding y value, and then you plot the xy pairs. Okay. And then another thing you can do is apply, if possible, one or more transformations to the graph of the parent function x squared. Okay. Apply the transformations that we did in section 3.5. Okay. The problem with doing that is that most of the time, well, not all, well, a lot of the times, you're not going to be given something that is in the format you need in order to apply transformations. For example, the first problem we're going to do in example 1, okay, example 1, the quadratic function is negative x squared minus 6x, okay? And when I look at that, I have no clue what to do. I don't know if I should be moving it left, right, up, down, if there's some kind of reflection. It's not in a format where I can recognize a transformation. So you can't do transformations there. Sometimes, and we've seen this in section 3.5, you saw examples of where you could identify the parent function as being x squared, and then applying the transformation rules, you knew how to move it around. So my point is you can only use method 2 if the function is written in a format where you can easily recognize the transformations. Okay. If you just have a flat out ax squared plus bx plus c, don't recognize any transformations, the best thing to do is what is outlined in number 3, the third technique. Okay. We are going to take our equation. We are going to identify the a, b, and c. We're going to determine whether the parabola opens up or down. We're going to calculate the vertex, okay, the axis of symmetry, the x and y intercepts, and then we're going to use all of that information to graph the parabola. Okay, and like I said, this is the most practical approach, and that is what we're going to do in the following examples.